Hello viewers on YouTube. In this video tutorial, we are going to focus on hyperbola. So as you can clearly see on the board, we have two different orientation of hyperbola. For the one on the left is an hyperbola with horizontal orientation, and for the one on the right is an hyperbola with vertical orientation. The equation that corresponds to the hyperbola on the left is expressed as x squared all divided by a squared minus y squared all divided by b squared equals to 1. And the equation that corresponds to the hyperbola on the right is expressed as y squared all divided by a squared minus x squared all divided by b squared all equal to 1. So please make sure you note the difference. The value of a when it comes to hyperbola is not always greater than b. It's not always greater than b. It could be greater than b, it could be less than b, and in fact it could be equal to b, where we'll be having a rectangular hyperbola. Is that okay? So now it's important for you to know under what axis the value of a is going to be if you are not given the equation of the hyperbola, and also if you are not given the structure of the hyperbola. Everything is what we are going to be discussing in this video. So just stay tuned and make sure you are following each and every step as you are progressing forward. So, somewhere along where the hyperbola opens toward is called the focus. So it's occur for both sides of the hyperbola. So we have another focus somewhere around there, and the distance between the center of the hyperbola and the focus is c units. Okay. Now for these hyperbolas, both the one at the left and the right hand side, their center is at the origin. Okay, thus the coordinate of the center is 0, 0. Now the equation we stated earlier actually corresponds to the equation of an hyperbola that is centered at the origin. As we progress forward in this video, we will discuss about how the equation changes if the hyperbola is not centered at the origin. So the distance between the center of the hyperbola and the focus is c units, and for the left hand side we have minus c units. Now we also have a point which we call a vertex. This is a point where the arc of the hyperbola touches the Cartesian plane, or it touches the Cartesian axis. So such as this one right here, the point I highlighted in green. So we call it a vertex. And the distance between that point and the origin of or the center of the hyperbola is a unit. For the left hand side will be minus a, and for the right hand side, if this is the vertex, we have positive a. So combined together we call it vertices. Vertex is a singular word, while vertices is a plural. So the coordinate of the vertices is for this kind of hyperbola that is centered at the origin and that is horizontal orientated. The coordinate of the vertices will be plus or minus a, 0. So you will see how the order changes if the hyperbola is not horizontally orientated. So please, all these things, there are things you have to put into account and consideration while figuring out your center, your vertices, and your foci. So now the next thing we actually need to discuss is called the foci. The foci is the coordinate of the focus. Okay, is the coordinate of the both focus, because we have about two focus in the hyperbola. You understand? So the plural name for focus is the one called foci. So the coordinate of foci will either be in red or yellow. The coordinate of foci is, don't forget we said from the center of the hyperbola, from the origin to the focus, for the right hand side is c units, and it is minus c for the left hand side. So we have plus or minus c, 0. For those might be wondering why we write plus or minus c, because this distance is c units away. We are trying to identify the coordinates of this point. Now along the vertical axis, it is 0 units away because it doesn't shift any unit from the origin, but it's shifted some units, which is c units away along the x-axis. So that's why we have it plus or minus c could be 0. Am I communicating it? Because it did the same thing for the left hand side as well. Perfect. Now let's talk about the coordinates of the vertices and the foci for the hyperbola on the right hand side as well. Okay, so for that being green, for the coordinates of the vertices, this is the first vertex and this is the second vertex. Okay, don't forget the distance from the vertex to the center of the hyperbola is a unit. Okay, so since this hyperbola is also centered at the origin, so it means we are going to have positive a units from here to this point. The center of this hyperbola is also 0, 0. So it means all the way down we are going to have minus a units. That should actually be minus a units. Okay, that's the coordinates of this point, or the distance between the center of the hyperbola and the vertex. So the coordinates combined be 0, plus or minus a. Okay, because these values now are y values. You can see they are actually along the y-axis. So that's why the order changes. So it's very, very important to know your hyperbola while dealing with any problems involving hyperbola, so that you won't be switching the exact answers in the wrong position. And so on. So it's very, very important. Now, for the foci, remember we said that is in relation to the value of c. So if the focus, I said the first focus is somewhere around there, because the focus will always be towards the direction along which the arc of the hyperbola opens towards. Okay, so if this is the first focus and this is the second focus, remember we said all the way upward for the positive axis there's going to be c units, so we'll have c limit here, and all the way downward for the negative y-axis that's going to be minus c units. So now since these values are y values, it means and the hyperbola is centered at the origin, then it means the focus is going to be 0, plus or minus c. Then this is the difference with that of the horizontal orientation. Am I communicating? Perfect. Now, having known how to express your vertices, your center and focus, and the equation of the hyperbola, the next thing you need to be familiar with is what we call the transverse axis. Okay, this is a line that joins the two vertices of the hyperbola. So if we have a straight line that connects the two vertices of this hyperbola, that straight line is what we call the transverse axis, and we can determine its magnitude. So its magnitude, let me just write it, transverse axis. Okay, so its magnitude is simply equals to 2a. So that's its magnitude. Basically, you notice that from this point to this point is minus a, but since we are considering distance, you understand, we just need to add it, since we are not talking about displacement. Okay, and from here to here is c equals to plus a. So combining them together gives us the total length of the transverse axis. So please, something you want to keep in mind. Now we also have what we call distance between the two foci, in case you have a problem that requires you to find that. The distance between the two foci is just equal to 2c. You just need to add the two values of c and get the distance between the two foci, because what that means, makes sense, is from here all the way to here. Next time we're trying to find the distance between the foci. Perfect. So I can also write that for you. Distance between VTW between foci is equal to 2c. Excellent. Now, same thing applies to the hyperbola that is vertically orientated. The transverse axis, which I've just write as TA, is equal to 2a as well. Hope you won't mix this up. This one is transverse axis. This one is the distance we are putting into consideration as the distance between the center of the hyperbola and the vertex. Okay, y, the distance between the foci, and so df is t equals to 2c. Perfect. Now, before we consider putting everything we have learned so far, let's quickly discuss about what we call an asymptote. Okay. Now, to be able to sketch an hyperbola properly, it is advisable to draw a rectangle first. This rectangle can be successfully completed if we have the value of a and b. Understand? Now, the value of a, if it is horizontally orientated, will be along the x-axis, and the value of b will be along the y-axis. By the time we connect those points, a will be of 2 values, b will be of 2 values too. So by the time we connect them together, we can get a rectangle. Now, this can help us to sketch the hyperbola because the arc of the hyperbola is just touches the edge of the rectangle, and from there we can have our proper hyperbola. So now, there's something called a diagonal. A diagonal is a straight line that's passed through the vertices of a rectangle. This is what I'm saying makes sense. Let's say this is a rectangle. Now, if you have a straight line that is drawn, this is a vertex. This is also a vertex. A vertex is a point where 2 lines meet. This is also a vertex. This is also a vertex. When we have a straight line that passes through one vertex all the way to the other opposite vertex, that line is what we call a diagonal. Now, an hyperbola possesses a diagonal. This diagonal is called an asymptote. However, problem will be in such a way that you will be required to find the equation of that asymptote, that line. And since that line is a straight line, with what you are clearly seeing, its equation will correspond to the equation of a straight line. So the equation of an asymptote, let me write it in green. I'll just write asymptote. What can I use to abbreviate it? Let me just say asymptote as. Okay. The equation, if the hyperbola is centered at the origin, is simply equal to y equals mx plus c. Understand? But remember, when we have a straight line centered at the origin, where it touches the y-axis at the origin, then the intercept, the y-intercept will be 0. Thus, the equation of the asymptote, y will be equal to mx. The problem now is, what would be m? Because you know that x and y are just the axes. Your m will be your gradient. So, you must know your hyperbola, very, very important. If your m is your gradient, remember, gradient means a rise over what? I said, this is the value of a, and this actually corresponds to 1, and this is the value of b, which corresponds to rise. So if it's horizontally orientated, the equation will be y equals plus or minus, so b is rise, a is 1 over a times x, xn's. The plus or minus gives us the 2 diagonals because it's going to be 2. It's going to be 2 that will be formed. One will be along the right hand side, the other one will be along the left hand side. The one that's along the left hand side corresponds to the minus part, the one along the right hand side corresponds to the positive part. Understand? So the equation of the asymptote, if the hyperbola is horizontally orientated, is plus or minus b over a times x. Am I communicating? Perfect. Now, if the hyperbola is vertically orientated, the equation of the asymptote would be, you just kind of flip the value of a and b, so that just be y equals plus or minus a over b comma x. Now, for those who might be curious, let me show you. Gradient is a rise over 1. Okay, the c part, how c is being get rid of, you should understand that by now, because the diagonal actually passes through the origin. It touches the y-axis at 0 because the center of the hyperbola is 0, 0, you understand? So that is why the value of c is 0. Now, we want to know why the value of m changes from b over a to a over b and vice versa, depending on the orientation of the hyperbola. This is because gradient is a rise over 1. For this hyperbola, horizontal one, the rise is the value of b. The run is the value of a. That's why it turns out to be like that. But for the vertical hyperbola, the rise is the value of a, as you can see. However, the run is the value of b. That will be this way. Understand? So that's why it becomes plus or minus a over b, times x. So this is what you actually need to be familiar with in order to successfully solve most problems involving hyperbola, you can be asked to find the equation, coordinate to vertices, coordinate to foci, transverse axis, the distance between the two foci, and the equation of the asymptotes. Now, to put this to good use, let's consider some practice problems. Example number 1. Given that the equation of a hyperbola is x squared over 25 minus y squared over 144 equals to 1. Find the coordinates of the vertices, the eccentricity, the coordinates of the foci, the length of the latus rectum, and the equation of the asymptotes. Lest I forgot, I didn't give you or made mention of how to find the eccentricity and the length of the latus rectum. So when we get there, I'm going to discuss it. So first, let's understand the problem. So we have the equation of the hyperbola to be given as x squared divided by 25 minus y squared divided by 144 to equal to 1. So the first question you will ask yourself whenever you want to solve any problems involving hyperbola is, what kind of hyperbola am I having? Is it the one that is horizontally orientated or the one that is vertically orientated? This is the first thing you have to put into consideration, because any other thing you have to be doing must be actually referencing to the orientation. Am I communicating? Perfect. So how can we tell what type of hyperbola we are having? To know what type of hyperbola you are having, if you are given the equation, pay attention to the axis that the positive sign is attached to. Now you can see that x squared is the one that has positive, y squared has negative, because negative sign is like the coefficient of this term. This tells you that it's an hyperbola with a horizontal orientation. If it is y squared that has positive sign, it's an hyperbola with a vertical orientation. Am I communicating? The sign can help you. If positive sign is attached or is associated with x part, is horizontal. But if the positive part is attached to or associated with y part, is a vertical hyperbola. Excellent. So if that is the case, this problem, this hyperbola, is horizontally orientated. Now that we know that, it means that our coordinates of vertices, coordinates of foci, coordinate of center, everything would be having the x parts. Are we there? But let's get the value of a and b first. Now, a will always be under the axis that has positive parts. A will always be under the axis that has positive part. For ellipse, in contrast to ellipse, a is always the largest one. But hyperbola, a can be more than b, a can be less than b, a can be equal to b. So for you to know your a, if you are given the equation, a will always be under the axis that has the positive sign. It means a squared here is 25. Remember, the equation actually corresponds to the form x squared over a squared minus y squared over b squared equals to 1. Am I communicating? Okay. So if a squared is equal to 1, a will be plus or minus 5 by the time you take the square root of 25. And b squared will be 144, which means b will be plus or minus 12. Excellent. Now that we have a, we can find the coordinate of the center and the coordinate of the vertices. Coordinate of the center will be 0, 0. This hyperbola is centered at the origin. Why is it 0, 0? Because no any value attached to the x and the y parts. So once you see that they are just alone, it means an hyperbola that is at the origin. But when another something or another value is attached to them, where everything is now in the bracket, then it means it's not at the origin. Perfect. Now for the vertices, remember, if it is horizontally orientated, then the vertices will have the x values to be higher. Since coordinates is of the form x, y, and our hyperbola is along the x-axis, it means x value will have the highest. Since this hyperbola is centered at the origin, it means the y value will be 0. And since the vertices is plus or minus a comma 0, for an hyperbola that's centered at the origin and horizontally orientated, it means our vertices will be v plus or minus 5 comma 0. Simple as that. Now we need the coordinate of the foci. We have jumped the eccentricity. Okay, we're still going to talk about the eccentricity. Is that again? The thing is, if we don't get the foci, then to get the eccentricity, we might be using a small kind of. I'm going to show you the equation. You see the equation. So getting the foci is much more recommended. So what will be the coordinate of the foci? Now we need the value of c. So there's a formula that connects the value of a, b, and c together. Is that again? So what's that formula? The formula is such that c squared is equal to a squared plus b squared. In contrast to ellipse, remember that c squared is always equal to a squared minus b squared. But for hyperbola, it's simply the sum. So this clearly means that c squared will be equal to a squared is 25, b squared is 144 from this point, okay? And the sum of these two is 169. So if we take the root, this is 6, alright? If we take the root, c will be plus or minus 13. The root of 169 should be 13. Excellent. So since c is 13, the coordinate of the foci will be plus or minus 13, 0. Yeah, because it should be along the x-axis. Okay, that will be the c. Now, we mentioned transverse axis earlier. We also mentioned the distance between the two foci. In case you might be asked to find it, they no asked us to find it there, then the transverse axis will just be 2a, and the distance between the two foci will be 2c, which is 2 times 13. So just keep that in mind. Now, the eccentricity. The eccentricity, you can determine its magnitude using two formulas. One is in terms of a and b, the other one is in terms of c and a. But I would suggest using this the c and a. E is just equal to c divided by a. You get your e. Now, if you don't want to use this formula, some textbooks will have our e as to be equal, but should not be squared. E squared to be equal to b squared over a, and we have it to be added with 1. But this can be a little bit too exhausting. This looks more simpler and friendly than this. So let me show you how they actually end up with this. Well, if we cross multiply this one, then we'll end up with EA to be equal to C. But C is A squared plus B squared. That makes it C squared, right? Now let's square both sides. Upon squaring both sides, this should imply that E squared, A squared should be equal to C squared. And that's when we can now replace with this, right? And this also implies that E squared, A squared equals to A squared plus B squared. Now we divide through by the A squared, and thus we're going to have that in red. E squared will becomes A squared over A squared plus B squared over A squared. Okay, now I'm supposed to put squared here. That's it. That's it. So we always want something simple. Now this is very easy to recollect without making any silly mistake. So now, this can cancel and becomes 1. I can now have E squared to be equal to 1 plus B squared over A squared, which actually corresponds to what we have here. So the choice is yours. If you are kind of person that prefer something very, very, how should I put it, then you can go with that. Well, this is better for us. So now, our C is 13 and A is 5. Eccentricity will be 13, 5. Simple as that. So now we have gotten the coordinates of the vertices, the eccentricity, the coordinates of the foci, and now we need the length of the latus rectum. So this can go. This can also go. Well, we actually need the value of C. I'm just going to put that somewhere. C is equal to plus or minus 13. Okay, the length of latus rectum, LR, for an hyperbola. Do you know what latus rectum is? Latus rectum is like a diagonal, but what it does is that it is drawn from one edge of the hyperbola to the other edge of the hyperbola. Not just hyperbola, the arc of the hyperbola. Here's what I'm saying makes sense. Oops, I need to make it black. I'm not straighten up. I have an hyperbola. This is the arc at the right hand side. This is the arc at the left hand side. So if you have a line drawn from one edge to the other edge of that arc, that line is what we call latus rectum. So to find its magnitude is always 2b squared over a. So that is how you can get the magnitude of the latus rectum. Okay. So now the value of b is 12. And we should have 2 times 12 squared. Well, b squared is just 144. So 144 divided by a is what? 5. 144 times 2 should be 288. And that gives us the length of the latus rectum. Now, finally, for the equation of the asymptotes, what do we do? Remember, the asymptotes we know that is a straight line, and the equation of the straight line is y equals mx plus c. So, since our hyperbola is centered at the origin, it means the equation we are going to be getting will be y equal to mx. We don't need the center, also we don't need the intercept because it is excellent. Now we need m. M can be plus or minus a over b, and it can be plus or minus b over a. The question is, how do we want to know which is going to be? Though I mentioned it earlier, but let me come again. It depends on the orientation of the hyperbola. If it is horizontal, then it will be plus or minus b over a. If it is vertical, it will be plus or minus a over b. Guys, overall, you can use the illustration I demonstrated earlier just to be able to recall it. Let me show you again. This, just bear with that. This means rise, this means run. Now, if it is horizontal, the value of a will be horizontal. So a will be 1. This is a, it will be 1. And b will be rise. This is b, it will be rise. So horizontal will be plus or minus b over a, like I said earlier. And just vice versa for the vertical. Just try to flip or reciprocate the fraction. So that's it. So therefore, the equation of the asymptote will be y equals to plus or minus b over ax, and that is equals to plus or minus b is 12, a is 5, x. Simple as that. That gives us a solution to this problem. How to find it here for understanding? For better understanding, let's consider one more example. Example number 2. Given that the equation of a hyperbola is y squared divided by 36 minus x squared divided by 16 equals to 1. Find the coordinates of the vertices, the eccentricity, the coordinates of the foci, the length of the latus rectum, and the equation of the asymptotes. So, I changed my mind. This should be an exercise because it's very, very similar to the example we just concluded. So, just follow the steps gradually. I can advert it and assure you that you are going to get the right answer. By the way, feel free to share solutions with me via the comment section below. Thank you. Now, we basically want to put into consideration an hyperbola that is not centered at the origin. What actually changes between their properties? So let's put that into consideration now. So I might need to bring this back after. So let's come back to this. Well, this is filled up. Let's form a new ball. If the hyperbola is not centered at the origin, I will need to hold it for you so you can see the difference. So let it be origin and let it be not origin. For the origin, the center is 0, 0, either it's the vertical or horizontal, we don't care. And for not origin, the center is expressed as h, k. For the hyperbola that is centered at the origin, this is like a summary of everything. that is centered at the origin and horizontal. I'll just put H, horizontal. The coordinate of the center is 0, 0. The coordinate of the vertices is plus or minus A, 0. And the coordinate of the foci is plus or minus C, 0. If it is horizontal. The equation of the eccentricity remains unchanged. It's still C over A. The length of the latus rectum still remains unchanged. Still 2b squared over A. But the equation of the asymptote is expressed as y equals to plus or minus b over a x. Those are the three things that you actually need to pay more attention to. Now, it is centered at the origin, okay, but it is vertically orientated. The coordinate of the vertices will be 0, plus or minus a. The coordinate of the foci will be 0, plus or minus c. And the length of the latus rectum remains the same, still 2b squared over a. The, what's it called? The eccentricity still remains the same, still c over a. But the equation of the asymptote, y, becomes plus or minus a over b x. Am I communicating? Perfect. Now, I almost forget. The equation 2 are different. So let me write the equations 2. So you can get everything in just one way. So you actually need to adjust down to it. Aha, thank you. So for the horizontal, centered at the origin, the equation is x squared over a squared minus y squared over b squared equals to 1. For the vertical, centered at origin, the equation is y squared over a squared minus x squared over b squared equals to 1. Now, not origin, but horizontal. Very, very important. This is what changes. This corresponds to the value along the y-axis, corresponds to the value of the x-axis. Yeah. So, what do you want to do? Just be taking the center, be adding this to those coordinates. Simple as that. Which means for the vertices, that will be plus or minus a plus h, 0 plus k, that's k, k. You get the vertices. That's all, simple as that. For the foci, since it is horizontal, and it is not at the origin, the foci will just be, you need to add the centers h, k to the coordinate of the foci. This is the foci, the coordinate of foci for an hyperbola that is centered at the origin. But since this one is not at the origin, just take this value that is highlighted and add the center to it. Simple as that. So that will be c plus or minus c plus h, 0 plus k is still k. Simple as that. Are we together? Perfect. Now the equation. Okay, let's talk about the asymptote. For the asymptote, it will be y equals to plus or minus b over a x. But the intercept now will not be 0. You must find c. To now get c, after you have done y equals plus or minus b over a, x, after you have put the value of b and a respectively, to get c, you now switch the value of y as k, the value of x as h. You now do the maths and solve for c. And after that, you now repeat this thing again by putting x and y, then put the value of c you have gotten. Yes, if we do example, you see what I'm saying makes sense. Okay, perfect. Now for the equation is expressed as, since it is horizontal, that will be x minus h all squared divided by a squared minus y in a bracket minus k all squared divided by b squared equals to 1. This is minus equals to 1. So there's 1 there. So that is the equation. Are we together? Perfect. Now, not at the origin, but vertical. Not at origin, but vertical. Pay attention to at origin, but vertical. At origin, but vertical, the coordinate is 0, plus or minus a. All we need is just to add the corresponding coordinate of the center. So that will be the vertices will therefore be v in bracket. That will be 0 plus h. H corresponds to the values along the x-axis. So 0 plus h is h, now k plus or minus a. That will be k plus or minus a. That is the vertices for the hyperbola that is not at origin but vertically orientated. Excellent. Now for the foci, you do the same thing. That will be 0 plus h. That's h. Okay, then we have k plus or minus c. Perfect. So k plus or minus c. In terms of the eccentricity, the length of the latus rectum, those ones, their equations, the formula that helps us to get their magnitudes are going to change. Okay, so once you have been able to find the exact value of a and b and c respectively, then you have no problem with those ones. Okay, perfect. Now for the asymptotes, y equals, since this vertical, will be plus or minus a over bx plus c. So this is where we are going to get c. I'm going to show you that by the time we consider an example problem. And lastly is the equation. Since it is vertical, it means the value of a will be under y part. And since a is always under the positive part, it means we can have y minus k all squared divided by a squared minus x minus h all squared divided by b squared equals to 1. And this is how the properties of the hyperbola actually varies depending on its center and its orientation. So I hope this can give you a clear insight of what actually distinguishes the two of them, and also how you can make use of them effectively depending on the structure you have. Now, we have already considered problems on hyperbola, that is centered at the origin, both horizontally orientated and vertically orientated. Yeah, the next thing is to consider not at origin. So, example number 1. Okay, this was the one I gave some. Identify the coordinates of the center, vertices, foci, and thus find the eccentricity, latus rectum, and the equation of the asymptotes of the given hyperbola. So this is a problem we have before us, which we are required to find almost all of its properties. So the equation is given as x minus 3 all squared divided by 4 minus y plus 2 all squared divided by 9 equals to 1. The first question is to find the coordinate of the center, C. So now you can see that we now have some values attached to x and y. Basically, you take each of these values and alternate their signs. That will be the coordinate of the center. Since this one is minus 3, you alternate it and turn it to plus 3. So that will correspond to the coordinate of the center. This is the bracket. Okay, I wrote C. Let me put the bracket first. C in bracket. So that will be plus 3, now this is plus 2. You alternate the sign and turn it to minus 2. And thus, you have the coordinates of the center of the hyperbola. This coordinate is what we are going to be adding to the corresponding coordinates of the vertices and the foci. Now, to get the coordinate of the vertices, we need the value of A. To get A, we must know our hyperbola. What type of hyperbola we have? Is it vertical or horizontal? How can we tell? That will depend on the sign that is associated to the vertices. And notice that x-axis is what has a positive sign, while the y-axis has a negative sign. Thus, we have a horizontally oriented hyperbola. And since A is always under the positive axis, it means this 4 is A squared. And that is the case. That implies that A squared is going to be 4, Thus, A is going to be plus or minus 2. And simple as that. So, having identified the value of A, we can get the value of B similarly. So, B squared will be 9, which implies that B will be equal to plus or minus 3. We get the value of B2. Now that we have the value of A, we can get the coordinate of the vertices. Thus, V in the bracket will be, since it is horizontally orientated, that's one, and at the same time, it is not centered at the origin. We mentioned it earlier. So the coordinate of the vertices will be what? It will be H plus or minus A, K. H is 3. Let me just put it on top. And K is minus 2. A is plus or minus 2. So that's what we're going to do right now. So V will be 3 plus or minus 2, K is what? K is minus 2. Excellent. Now, if you want, you can split this coordinate, and if you don't want, you can leave it like that. It's advisable to split it out. So the vertices will include 3 plus 2 is 5, minus 2, and 3 minus 2, 1, minus 2. So these is the vertices of the hyperbola. Simple as that. Now, the foci. To get the foci, we need the value of C. And to get C, we need to use the expression that connects the value of A, B, and C together. So what does it say? It says that C squared is equal to A squared plus B squared. This implies that C squared, A squared is 4, B squared is 9, and the sum is 13. Thus, C squared is going to be 13, and clearly implies that C is the root of 13. If C is root of 13, not just root of 13, but plus or minus root 13. Then the coordinate of this foci, since it's not centered at origin and horizontally orientated, that will be of this form F in the bracket. So it's going to be H plus or minus C, K. Excellent. So H is 3, remember, K is minus 2. It means the foci will be H, 3 plus or minus root 13, then minus 2. So just like before, let's split out the values. Then the foci will include 3 plus root 13, minus 2, and 3 minus root 13, minus 2. And simple as that. So, on to the eccentricity. Eccentricity is equal to C over A. Thus, our lowercase e is equal to C over A, and upon substitution, where we have C to be equal to root 13 plus or minus divided by A, which is 2 plus or minus. This plus or minus can be considered to be cancelled by themselves, and left over with just this. So that's the eccentricity. Now, LR, latus rectum, is 2b squared over A. B is 3. By the time we square it, we have 9. So 2 times 9 over A is 2. Latus rectum is just 9. Simple as that. And finally, is the equation of the asymptote. Remember, to get the proper equation of the asymptote, that also depends on two things. 1, the orientation of the hyperbola. 2, the center of the hyperbola. Since this hyperbola is horizontally orientated, it means I think this can go now. Yeah. Let me just write the value of C. We said C is plus or minus root 13. Since this hyperbola is horizontally orientated, the asymptote will be y equal to b plus or minus b over a x. But since it is not centered at the origin, it means we are adding c to it. If at all it is at the origin, then no more c, because c is going to be 0. But now c is not going to be 0 because the center h, k, okay, sorry, h, k is 3, minus 2. So we're going to do something else to get the value of c, and I'm about to show you that. So what exactly is the gradient? The rise of a gun, that's just the ratio of B and A. Means Y will be equal to plus or minus. B is 3 and A is 2. Okay? And then we have X attached to it plus C. Now this plus or minus is still there. Not just like before, that we consider the plus or minus to cancel out for C over A. This plus or minus is part of a formula, you understand? Yeah. Now, how do we get C? We basically need to switch the value of Y with minus 2 and the value of X with 3. And then do the math to get the value of C. And at the end of the day, we will now try to reverse the process, but substituting value of C as whatever we have gotten. So what am I saying next? Instead of Y now, we want to put the value of the center, which is minus 2. So put minus 2 equals plus or minus 3 over 2. Now instead of X, we put the values of this, which is 3 times 3 plus C. Now we might be getting two values for C. That makes sense because we have two diagonals in the sun depending on the gradient. So that doesn't mean. So let's plot the signs. The first one, but let's multiply first. We have minus 2 to equal to plus or minus 9 over 2 plus C. So basically I multiply this 3 with this 3 to get 9. Now, what do we do? Well, this plus or minus is just for the 9 over 2 alone, essentially. That will be minus 2 equals to plus 9 over 2 plus C, or minus 2 equal to minus 9 over 2 plus C. That makes sense? So we have split everything. Now I multiply all through for the left hand side and for the right hand side here. We should have minus 4 equals to plus 9 plus C. So basically, minus 2 times 2 gives us minus 4. And then when I multiply this by 9 plus 2 times 2 gives us 9. Okay, and I basically need to multiply this by 2 also. So that should be plus 2C. Okay, or minus 4 equal to minus 9 plus 2C. Excuse me. So basically, I multiply minus 2 minus 2. Now, this 9 can come all the way to this point, and the minus 9 can also do the same thing. Then we can have minus 4 minus 9 equals to 2C. Okay, and minus 4 plus 9 equals to 2C. So, minus 4 minus 9, that's minus 13. Minus 13 equals to 2C, or minus 4 plus 9 is plus 5. Plus 5 equals to 2C. Now dividing through by 2, we should have C to be equal to minus 13 over 2, or C should be equal to 5 over 2, or C should be equal to 5 over 2. So these are the two values of C, which we can now get our final equation of asymptotes. So remember, let me bring it back. I actually need to show you something. We get the value of C to be minus 13 over 2 when the gradient is considered to be plus 9 over 2. Okay, when it's considered to be plus 9 over 2, that's when we used plus 3 over 2. So it means, this is what I'm trying to do. If the first equation is y equals to, we'll consider the plus 3 over 2x. Now, the value of C will be minus 13 over 2. Yeah, that's exactly what I want to show you. So you should be able to put the appropriate values of C in the right equation. Then the second one will be y equals to, when we consider minus 3 over 2x, when the gradient is minus, we'll get 5 over 2 and plus 5 over 2. So that is the intercept. So that is the equation of the asymptotes, and it's simple as that. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. So the exercise I give you, feel free to share your solution via the comment section below, like I said earlier. Thank you once again. Bye.